We're going to do 3 examples. The first one is if you have ax plus b. I've already showed you how to take the antiderivative of this. So the answer to this would just be minus cos 5x divided by 5 plus c. I just want to show you that you could also treat this as a substitution question. So let's do that. So we could let u equal 5x because we know how to find the antiderivative of sine u. And the derivative of 5x is just 5, which is a constant. So we get du dx is equal to 5, so du is equal to 5 dx. So then we can do the substitution and we would get a 5 sine u du. So let me just show you that. So the du, sorry, let's just back that up. I made a mistake here. Forgot to bring the 5 over. So 5x, so then dx, and then this is 1/5 du dx. So we can replace the dx with 1/5, so 1/5 and du, and then we can replace the 5x with u. So there we go. And then this just becomes minus 1/5 cos u plus c, and then I just replaced the 5x with the u. So you can see that you could do a substitution question, or if what's inside is just the derivative is just a constant, then I already showed you how to do that using the 5 rules with the ax plus b. Okay, so hopefully that made sense. Okay, we're going to do a definite integral example, just so we have another one. So we're going to let u equal x squared, and then du dx is equal to 2x, and then du is equal to 2x dx, and I don't need the 2, so I'm going to bring it over to this side, and then x dx. Okay, and remember I showed you 2 methods. I'm just going to pick a method, so I'm going to change everything to u and just let it equal. So I get a half, and then e to the u du, and then I have to change these over by making it 1 squared and 2 squared. So again, these are x values, and to make them u values I use this, and so they're changed over to u values. And now I have 1/2 e to the u, and I don't need the plus c because it's a definite integral, and 4 and 1, and I get 1/2 e to the 4 minus 1/2 e to the 1. Okay, that's one way to do a definite integral. The other way is to do the question like we did the first example and sub back in and then put in the values. So as long as you change these over to u values, then this integral will equal the same as that integral. All right, let's try one more. Okay, so this is definitely a more difficult example, and maybe with a more difficult example, I might actually tell you what to use as your u value. So I do in this one, so we're going to let u equal 5x plus 1, and then du dx is equal to 5, and then du is equal to 5 dx, and I don't have a 5 up there, so I'll make it 1/5 du dx. Okay, so if I go to substitute in here, I get the integral, and then I get u to the 1/2, all of this to the 1/2, Okay, so that part's good. And then I get du and the 1/5, but I'm still left with an x, so that's a big problem. Okay, luckily, this can be rearranged. Okay, so we can take this and we can say 5x equals u minus 1 and x equals u minus 1 divided by 5. Okay, you need everything in terms of u. So then you get 1/5 u over 5 minus 1/5 times u to the 1/2 du. Okay, and we should be able to FOIL that out. And so we get u to the 3/2. This is 2 over 2. And then over 5 minus u to the 1/2 over 5 du. Okay, and then I'm going to pull out another 1/5, so I have 1/25 out here. And then u to the 3/2 minus u to the 1/2 du. And you should have brackets here. And then this is going to equal 1/25 u to the 5/2 divided by 5/2 minus u to the 3/2 divided by 3/2. Again, I'm adding 1 and plus c. Okay, so let's just do this out. So dividing by a fraction, I can multiply by the reciprocal. So I get 2 over 125 u to the 5/2 minus 2 over 75 u to the 3/2 plus c. Whew, that was a lot. Okay, and then to actually answer the question, which was 5x plus 1 dx, I get 2 over 125, 5x plus 1 to the 5/2 minus 2 over 75, 5x plus 1 to the 3/2 plus c. Okay, so basically for this question, what we're doing is, because this is all to the 1/2, I can't bring this inside. So instead, I make this the u to the 1/2, and I change the x into the bigger thing by solving here, just rearranging. And then I'm able to multiply that back in. Okay, so I'll give you one of these to try.